And when they switched editions of the book a few years ago, they moved it to 1/6, which is now here. They added some other things. We just really need to do the polynomial and rational inequalities using test points. Okay, just a little bit of a technique for that. Take a polynomial, x squared, x cubed. Is it greater than or equal to 0, less than or equal to 0? Based a lot about its graph. You understand the graph, then that kind of gives you an idea. And sometimes you can figure out that way. We're going to go through test points because it's really going to work with rational inequalities as well. So basically, here's what you're looking at. X squared plus 3x minus 10 is greater than 0. All right, when I plug in a value for x, does it give me a positive answer or does it give me a negative answer? Well, what we do is figure out where it doesn't equal 0. So that's going to be the kind of what we call the break points or the critical points. So right here, figure out where it equals 0. So just think about that. So I'm going to say, all right, where does x squared plus 3x minus 10 equal 0? Well, factor it. Okay, let's go back to what we've done before. Factor that, if it can. If it doesn't factor, then you got to go in quadratic formula. But this one does factor into x plus 5 times x minus 2. And so you get x equals negative 5, and you get x equals positive 2. Okay, and I'm going to call those my critical points or kind of break points. That's the only place it equals 0. So everywhere else it has to be greater than 0 or less than 0. Okay, that's the only cases. So at negative 5, now it has to be greater. It cannot equal 0. So I'm going to put an open dot at negative 5 because it's not allowed to equal it. And I'm going to put an open dot at 2. And so everything else, when you plug it in, will either give you a positive or negative value. Well, I need to pick test points. Okay, so it's one of the things, if you saw here at that bottom, it says solve polynomial and rational inequalities using test points. Okay, so we're going to pick test points. I just need one test point from each region. Doesn't matter. So this is going to break our number line into 1, 2, 3 region. I just need one test point. So I'm going to use, and it really doesn't matter. I'm going to pick x equals negative 8. And then if I ever can, I'm always going to use 0. I'll pick x equals 0. And I'm going to pick x equals 5. You got two options here. You can take negative 8 and plug it in and see what you get back. That's absolutely fine. You can take 0, plug it in, see what you get back. That's absolutely fine. Let me do something here. Whoops, never mind. But here's what I'm going to do. I'm just going to take this part right here. Okay, and I'm not going to write it every time, but I'll write it for this first one. So I'm going to take x plus 5 times x minus 2. And all I'm concerned about is the signs. Negative 8 plus 5, is that a positive or negative? Negative 8 plus 5 is a negative. Negative 8 minus 2 is a negative. A negative times a negative is always what? Positive. So that means no matter what point I pick in this region, it will always come back as a positive value. Okay, no matter what. So that's really all I care about. Plug in, all right, gives me a negative, multiply those together, gives me a positive. All right, if I pick negative 10, it'd have to give me the same thing. You can plug it in and get the number, but you don't have to. Well, we want numbers that give us that are greater than 0. Well, all those will be greater than 0. I'm going to use a test point of 0. Same thing. X plus 5 times x minus 2. And I'm going to evaluate it. Plug in 0. 0 plus 5 is a positive number. 0 minus 2 is a negative number. A positive times a negative is going to be a negative. So that means every point in that region will be negative. When you get to 2, it's going to be a 0. And now if you plug in 5, let's see what I get. So I plug in 5, x plus 5 times x minus 2. That gives me 5 plus 5 is a positive 10. 5 minus 2 is a positive. Positive times a positive is a positive. Okay, so for that. So what is my answer? What values of x are greater than 0? It's got to be in this region here, this region, then we get to 0, and then this region. So x exists. So for my final answer, x exists in the interval from negative infinity to negative 5. It does not include negative 5 because it doesn't say equal to. Union 2 to infinity. Okay. No matter what number I pick there, I plug it in, I get a number bigger than 0. Now this is tied to its graph. You should be able to think about its graph for a parabola. If it hits 0 at negative 5 and it hits 0 at 2 and it has a positive x squared, which way does it have to open? It has to open up. So if it opens up and it goes through those 2 points, okay, it should make sense that to the left of that 0 and to the right of that 0, those are all going to be positive values. So tie that together. I'm still going to use test points, but that should just be an extra confirmation. All right, same idea. X squared plus 4x is less than or equal to negative 6. It is not set equal to 0. Set it equal to 0. Whoops. I'm going to add 6. So I get x squared plus 4x plus 6 is less than or equal to 0. All right, first rule, factor. All right, take a look. What multiplies to 6 and adds a 4? Nothing I know of. All right, so if it doesn't factor, it doesn't mean it doesn't have zeros. It means it just doesn't factor. So what do we have to do? Quadratic formula. Do the quadratic formula. See what you get. I'm going to do it over here. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Opposite of 4 is negative 4 plus or minus 4 squared minus 4a is 1, c is 6 all over 2. What do we get inside? 16 minus negative 8? Is that right? All right, square root of negative 8 over 2. All right, we can actually stop right here. What does that mean? Does it hit the x-axis? No. All right, what do you think? What would be the answers, though, of our problem? What would be the answers of the situation? What numbers we plug in will be less than 0? So you got to think about this. If you get an imaginary complex number here, it doesn't actually hit the x-axis. Does this open up or open down? Just the general equation. Opens up. So where's it got to be located for it to open up and not hit the x-axis? Okay, it's got to be above it. Okay, because if it's below, like if the vertex is down here, it would have to hit it twice and it would have to show up as an answer. It does not hit it at all. So that means that it looks, and I don't know where at this point, but I know it opens up and is above the x-axis. So what's my answer? For what x values will they be less than 0? Will anything be less than 0? No solution. So this case here would be no solution. All right, just kind of a little bit of a forewarning. That's only with complex numbers. Let's just say you got an answer of, I don't know, negative 3 plus or minus square root of 2 over 2. What if you got that? Does that hit the x-axis? Yeah, those would be your 2 critical points. The only times it doesn't is if you get an I or a negative underneath the radical. So you just have to approximate where it hits. Negative 3 plus square root of 2, just take that decimal, figure out where it hits here, you'd still do your test points. Okay, so there's a difference between a irrational and a complex number. This one would have no solution. This one would have solutions, okay, for that if you got a case like that. Now, what we just had, we talked about that. It's called the one-sign theorem. So if a polynomial equation has no real solution, which means you got complex numbers, then the polynomial is either always positive or always negative. Okay, so it's either above your x-axis, or if it opens down, it's below it. Okay, so that'll kind of indicates like it's either going to be all real numbers, or it'll be no solution, depending upon whether it's less than 0 or greater than 0. So that's your one-sign theorem. So take your polynomial or your quadratic, factor it. Doesn't factor it, quadratic formula, and then you either get radicals, which are fine, or you get complex numbers, which means it's either going to be all reals or no solution. All right, so that's our one-sign theorem. Always positive or always negative. Now, that was just polynomial, or that's just quadratics. Hold on one second. All right, we're just going to do this one here. Now, I just want to talk about this one. Let me just talk about this one because time. The way it's written, we already know the zeros, right? The zeros would be at negative 3. You'd have a 0 there. We'd have a 0 at positive 2. We'd have a 0 at positive 8, right? So how many test points would I have to do? I have to do a test point for each region. So I'd have to do a test point, say negative 5. I'd have to do a test point, say 0, say positive 5, and say 10. So we're not going to do anything different there. We're just going to pick, we have an additional test point. So that's already in factored form. Don't multiply it out, make it more difficult. Leave it like that. All right, now if you get something like this, all right, let's do this one, number 2. X cubed is less than 9x. That equals 0. So x cubed minus 9x is less than 0. This one's not as obvious because you're not going to probably know the graph of x cubed off the top of your head. Okay. Whereas a polynomial, you should know whether it opens up or down if you know the zeros. So we're going to go through this similarly. We want to find where it does equal 0. Well, if you do have a GCF, factor that out. So you got x times x squared and minus 9. Keep going that route. Keep factoring. Well, x squared minus 9 factors into x minus 3 times x plus 3. Where will it equal 0? Whoops, it's just less than. It was equal 0 at x equals 0, at x equals 3, and at x equals negative 3. Those are your critical points. That's a bad C. Those are your critical points. All right, so I'm going to plot those. Negative 3. Actually, I'm going to do an open circle because it shouldn't equal that. I'm going to 0, 3. Now I got to find test points. So I'm going to pick negative 6. Test point. I'm going to pick negative 1. Doesn't matter whether it's negative 1 or negative 2. Can't pick 0 because it makes it 0. I'm going to pick positive 2. And then I'm going to pick positive 6. And I'm going to substitute it into this general form right there. And I'm just worried about positives and negatives. So I got x times x minus 3 times x plus 3. All right, negative 6. That's just a negative. Negative 6 minus 3. Negative. Negative 6 plus 3. Negative. So in the end, the whole thing has to be what? Negative. The whole thing has to be negative. All right, do the other 2, or the other 3. Do your other 3. See what you come up with. Hey, next Thursday we do have our Veterans Day Assembly, and what this is, we'll be leaving from first period, so we will go as a class down to the gym. Okay, first period, and they'll have a spot for us to sit. I don't know what section we are in yet. All right, I'm plugging in -1. -1 for just x is negative. -1 minus 3 is negative. -1 plus 3 is positive. Those three together will multiply together to give me a positive. Positive 2. Okay, that's a positive for x. 2 minus 3 is a negative. 2 plus 3 is a positive. That gives me a negative. And now 6 is a positive. 6 minus 3 is positive. 6 plus 3 is positive. In the end, I get positive. So let me just mark this. So I get all negatives in this chunk here. I get all positives in this chunk here. At 0, it goes back to negatives. And at 3, it goes to positives. One thing you got to watch when you write your answers, use your critical points as the dividers. No, sometimes you just accidentally use your test points. So what did we want to know? We want to know less than 0. So I got two areas that are less than 0. Okay, this area here and this area here. And so x exists in the interval from -infinity to -3 union 0 to 3. And it does not include those values. Okay. Now, does it always alternate? Because some of you might be saying, all right, it went negative, positive, negative, positive. Does it always? No. A lot of times, yes, it does. Don't assume, though. Okay, don't assume, because the second you do that, it'll stay positive and go positive here. Okay, so be careful over there. All right, that's polynomial inequalities. Polynomials just have whole number powers, no fractions or no x's and denominators. All right, rational inequalities. All right, these are more difficult because you are not as comfortable with them because you don't really know what their graphs look like. I think polynomials, you have a very good understanding. You know, it's going to have some peaks and valleys. It's going to have some mins and maxes. It's going to hit the x-axis. With the rational inequalities you saw from the test and from what we've done, those all look a little bit different. What you cannot just worry about the numerator. We got to figure out the x-intercepts and the vertical asymptotes and use those as our critical points. So basically find where the numerator equals 0 and the denominator equals 0. So that's what we have to do. So we have to find where the numerator and denominator equals 0. Okay, for that. Well, first one, no problem. X minus 3 equals 0. X equals 3. Denominator, 2x plus 1 equals 0. 2x equals -1. X equals -1/2. Let's make this less than or equal to 0, if you would. We haven't done an equal to. All right, if the numerator equals 0, if you plug in 3, what do we get back for our answer? You plug in 3 in the original function. We get 0 over 7, which is just what? 0. Is that a solution? Does it make it equal to 0? Yeah. If I plug in -1/2, however, what happens with that? It's undefined. So can that be a solution? No, because it doesn't exist there. So even though the numerator is okay, the denominator cannot equal 0, period. So I got a graph here. Oh, what do I want to do here? 1, 2. I'll let that be 0, 3, -3. So that means at 3, let me use a different color. You're going to have a solid dot because it can't equal 3. At -1/2, that's got to be an open dot. Can't equal that. Okay, so it can equal the 1, can't equal the other because -1/2 makes it undefined. Now you got to pick values, test points. Test points. So let's use x equals -3. I want to use x equals 0, even though it's close to that point. That really doesn't matter. And I'm going to use x equals 5. I'm going to do the same idea. All I care about whether the final answer is negative or positive. You can plug it in and get an answer that's absolutely fine. I'm just going to worry about negative or positive. So for that, I'm going to go back to the original. X minus 3 over 2x plus 1. If I plug in -3, -3 minus 3 is a negative. 2 times -3 is -6 plus 1 is a negative. In the end, it's going to be what? Positive. So that means everything here till I get to that critical point is going to be positive. All right, the same idea. I'm going to plug in x into x minus 3 over 2x plus 1. I'm going to plug in 0. 0 minus 3, negative. 2 times 0 plus 1 is positive. Negative divided by positive is negative. So everything in between those two critical points is negative. Now plug in 5, either mentally or on your paper, whatever. Think about what that's going to be. I'm just concerned about my final sign. Is it negative or positive? X minus 3 over 2x plus 1. If I plug in 5, 5 minus 3 is positive. Bottom is positive. I end up with positive. All right, so for this whole thing, what did we want answered? Less than or equal to 0. Where the negatives are. So x exists in the interval from, this is -1/2. So it doesn't include -1/2 to +3. Okay, so just that single interval. Now you got a vertical asymptote at -1/2. Remember how that breaks up the graph? Remember, these all look a little different. Okay, let's take a look at one more here. All right, this is greater than or equal to. All right, we got equal to and greater. All right, 2 over 1 minus 3x. Greater than or equal to 1. All right, your first instinct is you're going to want to multiply both sides by 1 minus 3x. That won't work. Okay, you got to forget that. It's with an inequality. What we got to do is you got to do, like we've done before, set it equal to 0. Okay, because we got vertical asymptotes, we got all kind of other things going on. If you multiply y by 1 minus 3x, you kind of change some things. Set this, get it where that's a 0. So I get 2 over 1 minus 3x minus 1 is greater than or equal to 0. All right, you're going to have to combine those to one term. So you're going to have to subtract them together. Get a common denominator and then subtract those. So 2, this is what happens here. So it becomes 2 over 1 minus 3x minus. That's going to be 1 minus 3x. That's going to be 1 minus 3x. That's going to be greater than or equal to 0. There it is. Now I'm going to take an extra step. Some of you might do this all in one, which is fine. But remember, if you got a minus in front of a quantity, this is how you would treat this. Is 2 minus the quantity, 1 minus 3x, all over 1 minus 3x. And so what do I end up with there? I end up with positive 3x. And then plus 1 over 1 minus 3x greater than or equal to 0. All right, at this point, it becomes the same problem as we just did. Find where your numerator equals 0, find where your denominator equals 0. Those are your critical points. All right, so let's do that now. So you want to, at this point, okay, find where the numerator and denominator equals 0. And so I get 3x plus 1. They're very similar, obviously. That gives me negative 1/3. Okay, that gives me negative 1/3. Subtract 1 divided by 3. 1 minus 3x equals 0. That's going to give you positive 1/3. Okay, positive 1/3. Now, I'm going to do the same idea. Those are my critical points. On my graph, I'm just going to make this 0, and it really doesn't matter where you put 1/3 and negative 1/3. Like, I wouldn't go by ones and try to scrunch it all in there. Just spread it out. It really makes no difference. Okay. So I got 1/3 and negative 1/3. I got to pick a test point. Oh, which one can it equal? And which one can't it equal? The numerator, it can equal, which is negative 1/3. So I'm going to put a solid dot there. Okay, it can't equal that. It cannot equal, the denominator cannot be 0 because it's undefined there. Regardless, that does not work. So at positive 1/3, an open dot. So it cannot equal positive 1/3. Test points, negative 1 will work. Okay, and I'm just going to estimate where it's at. I'm just going to use x equals negative 1, x equals 0, and then x equals positive 1. And then plug those in. All right, negative 1. What signs am I going to get? That's negative 3 plus 1. Negative divided by. What's that going to be? Just don't make it careless there. Make it careless there, the whole thing's wrong. 1 minus 3 times negative 1, that's going to be positive 4, right? It's going to be positive. Negative divided by positive is negative. So everything in here is going to be negative. All right, 0. That gives me 1 over 1, doesn't it? Positive over positive. So that final answer is positive. And positive 1. That gives me a positive over a negative. And so it's going to be negative. All right, now I did say that most of these will alternate. Not every one of them. I know all our examples have. Don't automatically assume that. We want greater than or equal to 0, right? Only spot that's going to work is in between negative 1/3 and 1/3, but it cannot equal positive 1/3. So x exists in the interval from bracket negative 1/3 to 1/3 parentheses. Not a lot of options. Well, actually, there's still an infinite number of options, but it doesn't feel like there's a lot of options. Okay, for that. All right, watch the rational ones. I'm telling you, these are the buggers. These are the hard ones because you're going to want to just say, I'm just going to multiply and get rid of that. It will not work, okay, for that case. All right. So we'll go back to page 155 for a minute. And you actually got a little bit of time here.